Let's look at finding the general formula or the nth term of a quadratic sequence. Remember, the formula for a quadratic sequence is Tn is equal to an squared plus bn plus c, where Tn is the value of the term, n is the term number, and a, b, and c are constants that need to be calculated using the formula shown below. So, find the general formula for each of the following quadratic patterns. We are given our quadratic pattern, which is 2, 6, 12, 20, 30, and 42, and so forth. We know that this is a quadratic pattern. Well, we don't know that yet. We need to determine whether this is a quadratic pattern. We will do that by finding our first differences. So 6 minus 2 gave me my 4 here. 12 minus 6 gave me my 6 here. 20 minus 12 gave me my 8 here. And I can keep going. 30 minus 20 gives me my 10. And 42 minus 30 gave me my 12 here. Now I can find the differences of my first differences. So 6 minus 4 gave me my difference of 2. 8 minus 6 gave me another second difference of 2. 10 minus 8 gave me a second difference of 2, and so did 12 minus 10 gives me a second difference of 2. So I definitely know that this pattern is a quadratic pattern because my second differences are all consistently 2. Right, to find the formula for a quadratic pattern, the general formula or the nth term, you need to set up equations. So you need to circle the first term of each line. So I circle the first term there on the top, which is 2, then the first term of my first differences, which is 4, and now the first term of my second differences, which is 2. Now I need to set up small equations for each one of these numbers. So let's start with the bottom. The bottom one, the equation is 2a is equal to 2, because 2 was our first value. The next equation is 3a plus b, and that we know is equal to the first value of 4. And the last equation is a plus b plus c is equal to the value there given, which is 2. So we have our three equations. 2a equals 2, 3a plus b equals 4, and a plus b plus c equals 2. We need to now solve each of these three equations, and you start with the second difference equation first, so the last equation first. So 2a is equal to 2, so a will equal to 2 divided by 2, which gives us a equal to a value of 1. Now this 1 you need to substitute into the next equation, which is 3a plus b is equal to 4. So instead of a, we know it's 1 because we just worked that out. So 3 times 1 plus b is equal to 4, which makes 3 plus b equal to 4. So b is equal to 4 minus 3 there, which is 1. So we know that our a value is 1. We solve for b, and our b value is also 1 in this case. On to our third equation, which is a plus b plus c is equal to 2. Now, a value we worked out is 1. Our b value we worked out is also 1 in this case. So 1 plus 1 plus c is equal to 2. Take all your constants over to the right hand side. C is equal to 2 minus 1 minus 1, and c is equal to 0 in this case. So we know our standard formula is Tn is equal to an squared plus bn plus c. Substitute our a value that we found, which is 1. Our b value which we found, which is 1, and our c value which we found as 0. That makes it Tn is equal to 1n squared plus 1n plus 0, which simplifies to Tn is equal to n squared plus n. And that is the general formula for this quadratic pattern.